All right, so we were, excuse me, excuse me, we're recording here. Let me go to the other class right quick, the Math 88 part of it, and just to kind of show you that I have uploaded a new skill review, and I kind of put it due for this Sunday, but I'd like you to work on it today. And we're going to start a review process for building up to the next test. So you'll see that the first one, and I'll show you what it is, but there's a new document that you can download, and I'll show you what it looks like as well when you go to do it. Let's see. Yeah, so here you go. So it's in PDF or Word document form, and here's what it looks like, just to kind of give you a heads up. Where's it at? Share, Word. So it looks like this. So I gave it to you in Word form in case you need to make it bigger. You can zoom on your end too, but in case you want to adjust the font or something to make it bigger, because sometimes it's not very clear as to it coming through, like, see exponents here of y to the sixth. I don't know if that's going to come through clear on your end, so I gave you both forms so you can make it bigger. And all you need to do is just submit your answers, just like before. You can handwrite them and take a picture and submit that. You can type it on here if you want to do that too. Your call. You've got both formats, however you want to do it. But you'll see here the problems, they go over kind of what we've been doing. The rules of exponents, finding the greatest common factor, taking out the greatest common factor, doing some multiplication of the binomials, the special factors sort of stuff. So I'm tracking the assignments, if you will. So hopefully you find the assignments helpful to doing this. And then I'm going to create, probably for tomorrow, I'll create another, maybe, I'll create another one to kind of go over the second half of everything as well. The factoring of trinomials, the grouping method, things of that nature that's going to appear on the second test. So just to kind of give you a heads up on that. And so I'll give you that tonight that you can start working on, but kind of look to get it completed. And as just like the prior reviews, this is pretty indicative of what's going to appear on the quiz, on the test too. So my goal is not to make these tests undoable. There may be one zinger, but 10 questions tracking along what we've been doing in the class as well. So very much like that first test that we went over. So give it a shot. I think you'll find that you're prepared for it. I hope you do, because at least, let me say it this way, what I've noticed here in us doing our work the last couple of sessions, it feels like you're feeling good about the rules of exponents, feeling good about multiplication of binomials and whatnot. So at least that first part of it. So the next review will probably have radicals, factoring, yeah, more factoring, and then radicals as well. So I forgot, where did we leave off? Oh yeah, we have to finish this. So it says, so we didn't get there. It said October 20th. I'm going to push that along a little bit, but we need to do this stuff right here. Whoops. We need to do this one, and this one. And this is going to end, like I said, this is going to end the test 2 material. So once we get through this, we'll be in good shape for it. Now, the stuff we do on radicals is going to come up when we do this stuff right here. So, but that's more to come, and not to worry about it just yet. Okay, so let me sort of pause. Any questions on anything leading up to it? Complex numbers. We talked about the clock issue. Anything on factoring? Any questions burning right now? Okay. Well, interrupt me if there are. So what I'll do, so we finished sort of the complex numbers, and I hope that you found that you were able to do that one, complex numbers, because really it just boils down to your rules for combining like terms and multiplying binomials, joined with this idea of the clock that we talked about. I minus 1 minus I, and then 1, kind of going in that clock fashion. So let's then move forward, and we'll do square roots in the Pythagorean theorem. We'll do the quadratic formula, and we'll do factoring by that. The cool thing is that you actually already know how to do a lot of this stuff. So again, it's just sort of a mashup. We're taking stuff you already know and we're putting it together. So it's not learning new stuff. It's learning new, kind of what are the steps more than anything. Um, and so actually, let me kind of go out of sequence a little bit. Let me hit section 3.R.8 first, because that stuff you already know. It's just factoring stuff, and it's a good sort of opportunity for us to review. Um, so we'll just kind of do a few problems here, but I'll tell you the gist of it, of what we're doing. So before we get started, what is the gist? Let me skip this one just a little bit. I'll come back to it a little later. So what is the gist of some of this stuff? Before we get too deep into it, hold on, my kids are climbing the stairs. So what we're doing when we talk about solving quadratic equations, and particularly when we solve it by way of factoring, and you see here it asks you to factor. What are we doing is, remember what factors are. It's a number. Whoops, hold on. Factoring is a number multiplied by another number. Okay, that's what factoring is, two numbers. And in this case, what we're trying to do is we want to get it, set it equal to 0. Okay, so if we have the product of two numbers where the product is equal to 0, what must be true? What must be true? So we have two numbers, A and B. We don't know what they are, but we can surmise what one of them has to be. If the product is 0, what do we know? Either A is 0 or B is 0. They could both be 0 too, but 0 times the number, 0, 0 times the number, 0, or 0 times 0, also 0. So that's what we know, and that's the whole goal when we're solving quadratic equations by the factoring method, is we want to factor it and set it equal to 0, because one of them is going to be 0. That's the gist behind it all. Now, when we do this, though, the key to it all is that the right-hand side has to be equal to 0. So if we have something like this, x squared equals 49, the 49 on that side kills it. We cannot have that. We need to get the 49 on the same side as the x squared. So that's a little bit different from what we've been doing, but it's unique to solving quadratics. So let me ask you, how am I going to get that 49 to the other side of the equal sign? And you would say, from your days of solving equations, how do you move terms from one side of the equal sign to the other?
Divide.
It's tempting to divide.
Do the opposite when it
So,
falls.
so what would the opposite be then?
To subtract it.
Subtract. Subtract, right. So this 49 is positive, so we're going to subtract 49, and we're going to do it to both sides. Okay, oops. So it's a little messy right there. So I'm going to take that off because it is a real giant mess. But what ends up happening is by subtracting that 49, we get this. X squared minus 49 equals 0. Now at this point, you factor with the right-hand side being 0, you factor that x squared minus 49. And how would we factor x squared minus 49? So remember the factoring processes. Count your terms. How many terms do we have?
You have 2, so you would square root it. Square root the x to get rid of that square on it. So you would also square root. And I'm not making any sense. I'm gonna shut up now.
Oh, that's fine. No, I think you're actually right. I think you're using different terminology, but I think you got it right. So remember the methods for factoring. This is a good review. The GCF you always look for, but the other methods, remember what the other methods are. Difference of two squares, trinomials, grouping method. 2 terms, 3 terms, 4 terms. If it's got 2 terms, you should be thinking difference of 2 squares. So is this a difference of 2 squares method? It may not be. We gotta go through the steps. Is it a difference of 2 squares method?
Yes.
Because it's 2 terms
With
with
a subtraction sign.
minus sign, and what about the terms?
Perfect squares.
Perfect squares, right? So I think it was Lola. I actually, but yeah, essentially think of it as the square root. So x squared, and then minus 7 squared. Treat them as square roots. So what's the square root of 49? It's 7. So we write it as 7 squared. So now that we write them as squares, how do we factor it? Excuse me.
You have 2 sets of parentheses. You set up 2 sets of parentheses first.
Okay. And what's going to go inside?
X plus 7 and x minus 7.
Perfect. Or x minus 7, x plus 7. Doesn't matter the order. Perfect. Right. Oops. X minus 7. Okay, so that's the factoring. So now what? Well, this is the new part. At this point, remember the concept. Either this is a number, okay? Either this thing is 0 or the first or the second factor is 0, okay? Either or. We don't know which one. Could be both. So what you do is you just set each factor equal to 0. So you say x plus 7 is 0, and then x minus 7 is equal to 0. And so essentially we broke it up into 2 linear equations like we had all the way back in week 2. All the way back in week 2. So that means what? What's the solutions? Well, either x is negative 7 or x is positive 7.
Because a negative and a positive cancel each other out, that probably means that both the factors are 0.
Well, yeah, either x can be either one. We don't know which one it is. But what we're saying is it can be, the solutions would be whatever makes it 0. And so either 7 or negative 7 simultaneously. Could be both. So that's the thing here, is that when you're dealing with quadratic equations, you'll have 2 solutions. Most of the time you'll have 2 solutions. And the giveaway for this is that exponent of 2. That tells you how many solutions you have. It tells you what we call roots, but solutions, okay? So step 1, make sure that the right-hand side is equal to 0. And if it's not, you got to get it there. Step 2, factor it. And then step 3, so this is step 1 right here, get the right-hand side equal to 0. This is step 2, factor it. And this is step 3, set each factor equal to 0 and solve for x.
How would you type that in for an answer then?
Well, this one right here, all they wanted was just basically, how do you factor it? Factor the left-hand side. So here, all they wanted was this. Oops. So this is what you would do. That's what they want. That's what they want here. They want you to factor it. Okay, so we're really just going to rinse and repeat this process. Get the right-hand side equal to 0, factor the left-hand side, set your 2 factors equal to 0, and solve for x. So here's another one. X squared plus 8x plus 15 equals 0. Does it have a GCF? Oh, let me ask it another way. Let me start. Is the right-hand side equal to 0? So step 1 is done. Step 2, factor. Factor the left-hand side, x squared plus 8x plus 15. Can we factor the left-hand side? Which method would we use?
Method for trinomial.
Trinomials, because it has 3 terms, exactly. Now, this is a trinomial. What's the leading coefficient of this trinomial?
1.
1, because it's just a plain x squared. So how do we factor something like that?
Where I get confused is, I guess there are two things that I want, like two different things I kind of want to try is to multiply a by c, which is the x squared by 15, or to find two numbers that
Let me tell you this.
okay,
The multiply a by c works on this too.
okay,
You can do that. Because
great.
what is a here?
At 1,
What's c?
15,
15. So you're looking for so 1 times 15?
15.
So you're looking for the factors of 15.
Okay,
So it still works out. But if you want to think of what, I totally subscribe to that. If you want to think of just that method, a times c, it works for every trinomial. So
oh really? Oh,
yeah, you don't have to really learn 2 different rules.
okay,
So what are the factors of 15? What are we looking for? We're looking for the factors of 15 that will do what?
that will add up to 8.
8. So what are those factors?
3 and 5.
So then what does that make each of these become?
To x plus 3 and x plus 5.
Right. So what does that make the solutions? What does x equal then? Well, you'll start to get the hang of this, but you set each one equal to 0. X plus 3 has got to be 0, and then set x plus 5 to 0 as well, and then solve for x. So here, what does x equal?
-3.
-3. And then here, what does x equal?
-5.
-5. So that's what goes in here. -3, -5.
All right.
Get the right-hand side to 0, factor, set the factors equal to 0. It's stuff you already know how to do, and we're just putting it all together. That's the cool part about this stuff. Let me pause here. Questions so far? And so hopefully what you're seeing here is that this lesson is nothing but a review of your factoring methods, 3.R.8. That's all it is. So let's do a couple more because we're really not going to get too much more fantastic than this. But this is a difficult problem. This is what we call a challenging problem, but it's really not because you know how to do this one. X times 2x plus 4 equals 3 times 3x plus 1. Remember what we're trying to do. They're telling you it's a quadratic, okay? So this is the method for doing, what we're talking about is the method for solving quadratics. Step 1, get the right-hand side equal to 0. Now, before we go about doing that, we got parentheses. What do we do with these parentheses?
Distribute.
Distribute. Exactly. Get rid of them. So take the x and multiply it inside. Take the 3, multiply it inside. So the very first thing we get then is, by doing the distributive property, 2x squared plus 4x on the left side of the equal sign equals 9x plus 3. Now that the parentheses are gone, now you get everything to the left-hand side. So how would I do that?
Subtract your 9x from your 4x on the other side.
So subtract 9x, and then what else?
Take your 3 and move it over. It'd be -3.
And also subtract 3, right?
Yeah.
So let me change my color ink. on that one. And also subtract 3. Oops. So then when I do that, what happens? Well, we'll bring the 2x squared down. Nothing combines with that. 4x minus 9x becomes minus 5x. And then the minus 3 doesn't combine with anything. Equals, this part goes away. They cancel. 9x minus 9x is 0. 3 minus 3 is also 0, leaving a 0. Good. We got the right-hand side equal to 0. That's what the challenge, that's really what the challenge is in this case. Now we factor. And here, it's a trinomial, so you would use the AC method. A times C. So I'm going to come over here on my scratch sheet of paper. A times C gives us negative 6, because it's 2 times negative 3. So what are the factors of negative 6 that add to give us the middle value of negative 5? Well, that's negative 6 times 1. So I break this up. This minus 5 becomes minus 6x plus 1x. Oops. And then I just bring down the 2x squared and the minus 3. So once I do that, how do I proceed on the problem? Grouping method. 4 terms. Grouping method. So let me change my pen now. I'm going to go to a pencil. Grouping, 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 grouping. Leaving me what? I pull out a 2x here, and I get x minus 3 plus also x minus 3. 1x is the same thing as x minus 3. So I've run out of room. let me push it up a little bit to right here. I'm going to pull out that common x minus 3. And what's that going to leave as my other factor?
2x plus 1, I'm gonna guess, because there is no number in front of that.
There's a 1 in front, right? We have to remember it's still there. That's the factoring. So get the right-hand side to 0, step 1. Factor the resulting trinomial, if you can. Now we set the trinomials equal, the factors equal to 0. So I got to come up here. I'm running out of room. It's a big problem. It's a long problem. So x minus 3 is 0. And then we also do, I'm going to take this off. It's just eating up all my space. And then when I set the other one, 2x plus 1 equals 0. So the top one, what does that give me for the solution of x?
X is equal to positive 3.
Positive 3. Add the 3 to both sides. Right. How about this one right here? What's my solution for x here? 2x.
Positive 2.
Close. Close. You got to get rid of that 1 first. Goes all the way back to week 2 now.
Oh.
So you got to subtract that 1 from each side. What does that give you?
2x is equal to negative 1, and then you have to divide it by 2.
2x is equal to negative 1. Right. And then divide both sides by 2. That's the other solution. X is equal to 1/2, negative 1/2. So you can and likely will oftentimes get fractions as solutions. Perfectly fine. Doesn't change the process though. It just requires you to kind of remember, oh yeah, solving equations. But still the same steps. Get the right side equal to 0, factor, and set each factor equal to 0. It was just a bigger problem. Questions? That's pretty much it on this one. The only other thing they would do to you, this is a big problem. This would be a challenging problem, a level of, difficulty high. If only because it's a lot of steps, isn't it? Still the same process, but it requires you to do more and kind of consider more. But that's really it. It's just the level of difficulty is a little higher, but it's still the same steps. This would probably be one of the more challenging questions. Not really something I'm interested in asking in a test, but I may.
And
I think you could do it. So let's see. Oh, how about this one? 6x times x minus 6. If you notice, it's already factored, right? So when it's already factored, you don't have to do the factoring. What would we do? Well, you skip ahead to the last step. Set the factors equal to 0. So set 6x equal to 0, and then set x minus 6 equal to 0. So what is the solution of this one right here when we for the 6x equals 0 part?
Minus 6? Negative 6x? Well, negative 6.
What's the operation between the 6 and the x?
You have to subtract it from the x. Or no, you actually have to divide it, wouldn't you?
Divide. So
Yeah.
then what does that make the solution become?
0/6.
And what's 0 over 6? What's 0 over 6?
Just
0.
6.
oh,
Test it. Let's see.
zero? Because if you have 6 people and 0 things to give them, too bad.
Just remember, 6 times x equals 0. They're multiplying each other. It gives a 0. So x has to be 0. That's the only number it could be to make the whole thing become 0. Or go through the process, divide both sides by 6, do it on your calculator, 0 divided by 6, and that'll give you 0. And what about this
Yeah,
solution
thanks,
over here?
Addie, for explaining it like that, because either way I would have said 6 and I would have been wrong.
Make sure you test it, though. You
Gotta
can
show.
test it. So what about this one over here?
That one's you add 6 to the other
The one
side.
you add
That's positive 6.
Right. Got it. And by the way, you can check your solutions. You don't need me. How would you check your solution? So these are our two solutions, 0 and 6. How would we check?
Plug your numbers in.
Plug your numbers in. So let's first test 0, okay? Let's confirm it's correct. So everywhere you see an x, you put in 0. So this is 6 times 0, 0 minus 6. Simplify using order of operations, PEMDAS. So we do parentheses first. 6 times 0 is 0. 0 minus 6 is negative 6. Does that equal 0? Yes. It gives us a true statement. So x equals 0, check. It is a solution. It is a solution. So now we have to check the other one too. We've got to check the other one too. So how would we do that? Well, the other solution is what? Positive 6. So everywhere you see an x, plop in a 6. It's a lot of 6s. Does it give you a true statement? Well, this one here is 36. 6 minus 6 is 0. Is that a true statement? Yes. Also true. So yes, x equals 6 is also a solution. So it's the same process for checking your solutions. It's just that now you have two solutions that you have to check instead of just one. Questions? So let's back out of this one. And now let's go, because really it's just the same thing. I mean, that last problem we did was probably the hardest one in my estimation. Um, let's then go to, so that was 3.R.8. Let's then go to the quadratic formula, 3.R.10, the one right above it. Because, again, this is stuff you already know how to do. It's just putting it together. And this is actually pretty cool because remember the factoring we were talking about with trinomials, A, B, and C? That's all this thing depends upon. So let me first start with this. If you take a look at this problem, negative 6y squared plus 5y plus 2 equals 0. You might be able to solve it using the factoring method that we just did. But keep in mind from our days of factoring, sometimes things don't factor, right? Sometimes things are what we call prime or not factorable. The quadratic formula can still be applied. So sometimes the factoring method won't work if it's not factorable. And so if it's not factorable, you have to use a different method, the quadratic method. Now, the cool thing about the quadratic method is it works on every quadratic equation, every one. And so because of that, I only use the quadratic formula. I almost never factor unless, I mean, Hawks is requiring you to do it sometimes. But I'm giving you a hint for the test is that if you get stuck on one, if you can't factor something, if it says solve by factoring or whatever, solve a quadratic equation by factoring, I'm telling you, you can use the quadratic formula as well. You don't have to factor because sometimes I would go, I would get a brain fart and I'm like, man, I don't know how to factor this thing. So quadratic formula to save the day is what I'm saying. So one thing to, so then when it comes to the quadratic formula, it does require the same condition as the factoring method, which is what? The right-hand side must be 0. In order to apply the quadratic formula, the right-hand side must be 0. And so if it's not 0, you got to get it 0 first before you can do anything else. So fortunately, this one is, okay? So we're in good shape. So once it is 0, don't worry about the variable anymore too much. What you're going to do is you're going to pick off the numbers in front. Okay? So I want you all to tell me what is the value for A, what is the value for B, and what is the value for C.
Like straight off for what they are right now.
Yep. Just from reading this.
That's easy.
Negative 6y squared is A, positive 5y is B, and positive 2 is C.
Very close. Almost perfect. One change. Don't do the Y. Just the numbers, not the
Okay.
Y.
So
So
would it for -6? Would it be 6 to the?
just
It wouldn't
negative
be 6
6.
to the second power.
No, because what is the power effect? Is the power over the 6?
Gotcha.
Just the 6 in front. No, I'm sorry, negative 6 in front. Just the 5 in front of the Y and just the 2 by itself. But the point is this was a review question fundamentally because you already know how to factor. The A is the value in front of the squared variable. The B is the value in front of the plain variable, and the C is the value with no variable. Cool so far?
Cool.
Okay, so now what? Now this is the thing people have nightmares about. This is the formula. That says the opposite of B. I think I wrote it as a 6. It's supposed to be a B. It says the opposite of B. It doesn't say minus B. it says the opposite of b. So if b is positive, opposite is negative. If b is negative, opposite is positive, okay? Plus minus the square root of b squared minus 4ac, and that's all under the square root, by the way. And then all of that divided by 2a.
I feel like you just came up with that for torture.
It's actually not. There's a song for it.
I know not.
I forget the
Oh,
side.
as long as it gets stuck in my head.
So let me see if I can put this in a.
Oh my God. So this is the formula for what?
This is the quadratic formula.
Oh, wonderful. Thank you.
X is equal to negative b plus or minus square b squared minus 4ac all over 2a. That's how our teacher had us remember it. So
That's
this
funny.
is bull.
Nice.
That's pretty funny. I never knew that song. Let me go over here. Okay.
Cool.
So I'm gonna do it on this one because I need a clean space. So can you remind me what are our values for A, B, and C? -6. I think B was
5,
5.
and then 2.
Yeah, thank you.
And then if you don't remember your quadratic, equation, she can sing it for you again.
Oh,
Please.
fortunately I
Oh,
was
absolutely, for a quarter. Because in this economy, I kind of need a quarter.
I forgot. Opposite of b, the square root of something. Okay.
Yeah.
Okay, so now it's just plug and play. Plug and play. So plug in your values. So B is 5. So when we go to minus B, you hit opposite and then put in your value of B, plus minus, and then square root. B squared, so B is 5, and then square it, minus 4. Plug in your value of A. Now put it in parentheses, minus 6. And then put your value of C in parentheses, 2.
So after the 4, is that an A?
It is supposed to be an A. Yeah. Let me get my pencil out. That's supposed to be an A. Okay, now the bottom, all of that divided by 2, and then plug in your value for A. All right, all we did was plug in the value. So identify your A, B, C, plug the values into the quadratic formula, and now what are we going to do?
Start putting things together.
Order of operations. Fundamentally, it's just the order of operations.
Where does square root fall into the order of operations?
Let me throw it to you all. Where does the square root fall into the order of operations?
I would assume somewhere between multiplication and division.
I would assume parentheses.
I don't know.
Parentheses.
It's in the
Treat it as a
parentheses.
parentheses.
But in order to get to that, you still have to do everything underneath it, right?
You got it. Before you can do the square root, you remember you can only take a square root of a number. It's
Yeah.
what we call a unitary operation. Add, subtract is binary. Multiply, divide is binary. It takes 2 values to do. Square root is like absolute value. You only take it of a number. It's unitary. So you got to collapse that stuff inside down to a single number, which means it's really a parentheses. There's an unwritten parentheses right around all of it that we just don't bother to write.
Yes.
So I'm going to sort of twist and jab a little bit. So the minus 5, we can hang out. We can go ahead and do this part down here. What's 2 times -6?
-12.
Negative 12. Now we take the square root. So
Uh,
essentially, go ahead and simplify your denominator. It is fine to do. You know, you're technically still in the parentheses step because there's a parentheses down here too. Because remember what we do with fractions, simplify the top down to a number, simplify the bottom down to a number. So there's really parentheses down there as well. But the real focus is all in here, inside the square root. So when you're inside the square root, apply the order of operations. So 5 squared is first, 25, minus 4 times negative 6 times, 2. But we can simplify that part down to what? What does this part simplify down to?
24 times 2 is 48.
What's the sign?
-4 times -6 is positive 24. Times 2 is 48.
Positive 48.
Sorry, it's positive.
So it becomes 25 plus 48. Now add 25 plus 48 gives us what?
73.
Mhm. Now at this point, when you have the square root of 73, you would ask yourself, can you simplify the square root of 73? Of course I can. I have a calculator. They don't want decimals. They want nice, neat numbers. So can we do it? Is there a number? Is there a perfect square that remember the simplification of radicals? Is there a perfect square that goes into 73? So things like 4, 9, 16, 25, any of those go into 73?
No, sir. It's like 8.5 and some change.
73 is actually a prime number, so nothing goes into it other than 73. So this is it. This is almost it. But we would normally be done here. Now, the only thing that's preventing us from being done is this minus sign. How do we resolve that? Well, we can technically see this part up here is plus minus. It's both. Okay, it's both positive and negative. So really what we do is we can just take this minus sign right here and change the signs of everything up here. Just change the signs. But what does that effectively mean? The 5 changes to plus. If you change the sign of plus minus, it just becomes minus plus, but that's right back to plus minus. It's the same thing. So we keep it as plus minus. And
So
then it becomes 12 in the bottom.
the reason that we had to do that is we can't have a negative on the bottom.
We don't like the negative in the bottom, right?
Why make your 73 negative then?
Yeah, why is that?
No idea. That's what I'm asking you.
Think of the square root. The square root is just like the absolute value. There's a force field around it. You can't break in unless you're inside a square root already. That's the only thing. So if you're on the outside of a square root, you can never get back in. It's a club. You don't have the right password. You don't know the right people. That negative is not breaking in there. It has to stay on the outside. And so the negative affects that symbol, the plus minus, not the number on the inside.
So if there's a negative on the bottom, you just don't want a negative on the bottom?
Right.
That's it.
So just change the signs of everything at the top, but not the stuff inside the square root.
Okay. So if it was already over like a positive 12, would we have to change the -5, or that's fine as long as it's not on the bottom?
If it were already positive 12 in the bottom,
Yeah.
we would leave everything alone in the top.
Okay.
We only change the sign at the top because We basically move the negative to the top. Or cancel, really what we did was we canceled the negatives. See, this negative here canceled with this negative here to make it positive, to make both of them positive in this case. So this is the answer. Not pretty, but it's the answer. And we would leave it like this because square root of 73 is a perfect answer. It's an exact answer. We just don't like decimals. So let's review the process. Step 1, you still got to get the right-hand side equal to 0, always, when you're dealing with quadratic, most of the time, quadratics. Step 2, in this case, quadratic formula, identify your A, B, and C values. Step 3, plug the values into the quadratic formula. And step 4, simplify. Using the order of operations. So let's then move to the next problem. Oh, so here they just wanted your A, B, and C, but we just went ahead and did the whole thing. So we're in good shape. Okay, so this question here asks, how many solutions does it have? There's 3 choices. And this is for all quadratic equations. You'll either have 2 different real solutions, 1 repeated solution, or 2 non-real, which we know are complex, imaginary solutions. How do we know which one is which? Well, it all boils down to what we call the discriminant. And the discriminant is this thing right here, this part, b squared minus 4ac. That's what we call the discriminant, AC. Okay? So you have 2 real solutions, 2 different real solutions when what? When the discriminant, when b squared minus 4ac is positive, greater than 0. Okay? When the discriminant, just that part of it, doesn't matter about the square root, just that part of it, when b squared minus 4ac is positive, something higher than 0, you will always have 2 different real solutions. You will have 1 real solution right here when b squared minus 4ac, the discriminant, oops, that's a terrible A. When b squared minus 4ac equals 0. It's a repeated solution, but you only have 1 repeated solution when b squared minus 4ac is 0. And if this thing in here, how do we know, remember how did imaginary numbers come up? Do you remember when we did that lesson? What does it mean to be an imaginary number? I. Remember I? Imaginary? What is I?
-1.
Close.
Sorry.
Remember I is the square root of -1. So complex numbers are situations where you have a square root of a negative value. Okay? So complex, imaginary, not real is a situation when your discriminant, b squared minus 4ac, is what? Negative, which means it's less than 0. Less than 0. Less than 0. Because that's what this is. That's less than 0. So those are the 3 scenarios. b squared minus 4ac is greater than, equal to, or less than 0. If it's greater than 0, you got 2 different real solutions. If it's equal to 0, you have 1 real repeated solution. And then when b squared minus 4ac is negative, less than 0, you got 2 complex values, non-real, imaginary values. Those are the 3 situations. So what do you have to do here? Whoops. What do we have to do here? You always have to start out. Anybody? I thought anyone want to take it? You got to get that guy over. You got to start off with it equal to 0. Always, always, always. So when we do that here, we get negative 3y squared plus 1 y plus 5, because we add the opposite. Now you pick out your a, b, c, okay? So in this case, a is negative 3, b is 1, and c is 5. So b squared minus 4ac, so that's negative 3 squared minus 4, oops, wrong. B is what? 1. I was looking at the wrong one. So 1 squared minus 4a, a is negative 3. And c is 5. So now you simplify this and see if it's positive, negative, or 0. Positive, negative, or 0. In this case, it's what? 61. So b squared minus 4ac results in 61. So how many solutions will it have? Two. Because it's greater than 0. Because the discriminant, b squared minus 4ac, it was positive. It was greater than 0. So that's how you tell how many solutions it'll have. Look at b squared minus 4ac, simplify it. Greater than 0, 2, equal 0, 1, 2 real, 1 real, or less than 0, 2 non-real. I think this is, now it's kind of all the same. So this one here, you apply the quadratic formula. B squared, A, B, and C, and apply the quadratic formula. So I'm going to kind of leave you at that. I'm going to try to see if we can do, I'm going to conclude here in just a second so you can work on that sheet, the review sheet, and kind of catch up on anything you need. But then you've got what you need here. Oh, let's see.
Professor,
Mhm.
the only problem that I'm having is when I go to, like, well, we was just at Hawks, right?
Yes.
So the only problem that I'm having is when they're asking for like a fraction with the square root and everything, and it's hard for me to kind of like put it in there when I'm like using the calculator. So like
How about
sometimes,
this? Yeah, how about this? Take a screenshot and send me the problem,
okay,
or point me to the problem if you can find it, because then I can look at it and see kind of what the issue may be. Wait, am I in the right
okay,
one?
I can do that.
In the wrong one? Okay. Did I do it right? Okay. So this one, oh, well, some of these are pretty straightforward. We already know. Perfect square, we got that one. Oh, we did this. Oh, this one here, when it says round to 3 decimal places, they want you to do it on your calculator. Take the square root of 208. So this is lesson 2.r.2. they want you to do it on your calculator in this one. When it says they want decimals, they want the calculator. I can tell you that right now. Same thing, decimals, so 4 decimal places. Do it on your calculator. Oh, okay, here we go. This is what we're looking for. Okay, so what's the path? Everybody remember the Pythagorean theorem? Maybe you do, maybe you don't. Not a big deal if you do or don't.
Yeah.
But it's a squared plus b squared equals c squared. All that means is what? When you have a right triangle, meaning one angle is 90 degrees, okay? When you have that, we call the legs the A and the B. So A is one side, is a vertical side, and then B is the other side, okay? The way to tell is that the hypotenuse, the C, is the diagonal side, okay? The hypotenuse is always the diagonal. I can tell you, always, always, always. So we're told in this one that A is 3. So plug in 3 for A. Leave the B alone, because we don't know that one. But the C is 16. So we solve the equation. We solve the equation. So what's 3 squared? That's 9. Plus B squared. What's 16 squared? I have no idea. So I'm going to break out a calculator. 256. Okay. Now, you could apply the quadratic formula to this. You could. How would we do that? Move the 256 over to the other side. So we subtract 256. So when we subtract 256, we get b squared minus 245 equals 0. So if we were to apply the quadratic formula, how would that work? What's your A, your B, and your C? Now, don't get it confused with A and B, C here. It's kind of weird. So you could still do, this is quadratic formula now. A, 1, oops, nope. Oh yeah, 1, 1, 1. Kind of weird. I hate using A, B, and C when they got A, B, and C here too. Oh well. You could use your quadratic formula. It's just that when you plug it in, your B in this case would be 0. Why? And the C would be negative 245. Why? Because there is no plane B. There's no plane variable. There's no plane variable. So no plane variable means 0 plane variables, something like that. So my point is, you don't really have to take notes on that, but what I'm saying is you could apply the quadratic formula to that. Still applies. Nothing changes on that. But there's an easier method. And here's the easier method. Because it's a b squared, because you have a squared term, but no plane variable, what that allows you to do, this is a special case. We can take this cat right here, this 245, and push it back over to the other side. Okay? So we'll add 245 to each side. And because we have this special circumstance with no plane variable, just a b squared part, we can take the square root of each side. We can undo the square by taking the square root. And when you do that, when you take the square root of a number, you got to account for both the plus and the minus. So I'm going to put that symbol in front, plus minus. And so when I do that, now we break out our calculator. Because they say they want 3 decimal places. They want 3 decimal places. So this becomes 245 square root 15.65. So it becomes plus minus 15.65. Well, 15.652. That's the answer at that point. But you have to put the plus minus. You have to put the plus minus. Which means that what? What's the solution? There's two solutions. One solution is what? B,
Positive.
yeah, positive 15.652. And the other one is what?
Negative.
Negative, right. That plus minus really represents two solutions, one positive, one negative. Good. Okay, so I'm actually late for my other meeting. I apologize. I'll apologize to them, not to you. uh, we're going to conclude early here, but I want you to go ahead and work on that review. Kind of, let's start some review because we're going to have our test next Wednesday. You've got this now on this one too. We're going to review it again tomorrow. So if you don't do this homework tonight, that's fine by me. Just we'll review it tomorrow. But you've got the quadratic equation because it's really just factoring, order of operations, all that jazz. It's just a mashup. And Zach, send me that problem, and I can a screenshot, and I can get you that. Okay.
Okay, I will.
Okay.
Thank you.
All right. Well, I'm going to go ahead and end this, but do work on the review sheet. Okay, and send me your questions. I'll be happy to help.
Okay.
Thank
All
you.
right.
Okay.
Thanks.
Have a great day.
You too.